everyone, welcome back to another video of Daily LeetCode Challenge Streak Series, and in today's video we have a new question: partition array for maximum sum. Given an integer array ARR, partition the array into contiguous subarrays of length at most k. After partitioning, each subarray has their values changed to become the maximum value of the subarray. Return the largest sum of that given array after partitioning. Test cases are generated so that the answer fits in a 32-bit integer. Now, what does the question say? You'll be given an array and you're supposed to generate subarrays of that array such that the subarray can have a length of at most only k. Okay? And when you get those subarrays, you're supposed to change those elements or update those elements such that the subarrays would contain the maximum element within the given subarray and it should return the maximum sum. For example, I have 1, 2, 3, 4 and 6. Now, and let's say k is equals to 3. Now, the subarrays that I can make out of this can be 1, 2, 3 is one subarray and 4, 6 is another subarray that I can make out of this array. Now, if you can see that k is equals to 3 here and I have my subarray length to be 3 and here it's 2, it's within 3, so it's fine. Now, I'm supposed to replace all these elements with the maximum of this element such that I will have a large sum in the end. I will get a maximum sum. So what will happen if I replace it like that? If I have 3 elements in my first array and 2 elements, let's see what happens. The maximum element here is 3. So 3 plus 3 here, 1 will be replaced by 3, 2 will be replaced by 3 and 3 will be 3 as well. So it's 9 here. And since 6 is the larger one here, so 6 plus 6 would give me 12. Now what is the overall sum? It is 9 plus 12, which is 21. Now let's try taking subarrays in a different order. Like, I will take the first array to have only 2 elements and the next 2 subarrays to have 3 elements. Okay, 3, 4 and 6. Now what I'll do again, I'll modify this to the largest element. Now 1 and 2. The 2 is larger one, so 1 will be replaced by 2 as well. So 2 plus 2 and here it will be 6 plus 6 plus 6 since 6 is the largest. So 2 plus 2 is 4, 6 plus 6 plus 6 which is 18. So 18 plus 4 is 22. Now if you have observed, what is the maximum sum among these two elements? It is 22. Correct? So you're supposed to divide these into subarrays of at most k length and get the maximum sum in the end. Now, how will you do it? Now, we can talk about 2 cases here. Let's say we have this array 1, 2, 3, 4 and 6. Now, what you can do, you can, without changing anything, you can take this thing and return the answer. Or what you can do, you can take the largest element here and replace everything by 6 here and then return the answer. But that's not the problem, because the condition for that is you can only have the k number of elements in a given subarray. So you can't take n elements if the condition is to have only k elements. Okay. Now how can we solve this problem? Assuming we start here. Okay, 1, 2, 3, 4 and 6. Assuming we start here, what are the possibilities? It can either have 1 element. The subarray can either have 2 elements or 3 elements or 4 elements, 4 as in k number of elements in a subarray. So for each and everything like that, now say if I only chose 1 element in my first subarray. Now again from the second element, 2 can have 2, 3 as a subarray, or 2, 3, 4 in a subarray, or 2, 3, 4, 6 in a subarray. Correct? Now if I take 3 like that, again I can only have 3, or I can have 3, 4, or I can have 3, 4 and 6. And now I have to check my k condition. Now k should be within this limit. So what I can do, I can simply have an I pointer and j pointer such that my window size will always be within k. Okay, I will make sure my loop will start at I. Okay, my loop will start at I and go till I plus k minus 1. Matlab, I say k elements. Okay. From I will take k elements because I can have at most k elements, and I will consider I will take all the combinations. If I is here, then I plus 1, then I plus 2 elements, I plus 3 elements, and so on till I plus k elements I will take. Okay, I will try all the combinations to get the maximum array. And what I'll do, I will keep updating my maximum value in every iteration. I will have my starting I value and this value, this will go until this, such that my I value and j value will be here first. Then the I value will be here, and then j value will move till here. Then I will be here, j will be here. Just I and j pointer is to determine the window size in which I'm going to take this element and change it. If for example 2, 3 and 4, my I is here and j is here. Currently this is my window size. Now I'm going to I want to get the maximum sum, correct? So what I'm going to do within this given window size, I'm going to take the largest element and I'm going to change, or I'm going to get my answer if 4 is updated with all the elements. Now how do I get it? If my window size, what is my window size here? It is nothing but j minus I plus 1. J minus I plus 1, correct? If for example this is 0th index and this is second index, how many elements do I have? I have 3 elements, which is 2 minus 0 plus 1. So my window size is j minus 1 plus 1. Now if I want this element to be updated here and I want to return it, I can simply multiply this particular element to this one, correct? I can multiply the maximum element in this window, okay, the maximum element in this window to this window size. So if the maximum element is 4 here and my window size is 3, so 4 into 3 is 12. I don't have to add like 4 plus 4 plus 4 every time. I can just take the largest element and multiply it with the number of elements in the given window and store it in a max variable, okay? And every time an iteration happens, I will keep updating my max value, okay? I will keep updating my max value and I will move my pointer by 1, okay? I will move my pointer by 1. Once the j is done, for example my I is here and I has finished all the iterations with respect to j, okay? For example k value is 4 and I started here j. The window size, the maximum number of elements can be 4. So what happens with respect to 1, 2, 3, 4 and 5? 1 to 4, I got the maximum sum and I stored all the elements with respect to 1, 2, 3, 4 in this thing. Now I want to check the sub arrays from 2 again, correct? Now I only started with 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, correct? Now I want to start from 2, 2, 3, 4, 2, 3, 4, 5. I want to start this, correct? Now what will happen in the end? After one iteration for this I to j finishes, I will increment this I by 1, okay? I will increment this by 1 and call this function all over again. I will keep doing this until the elements are done, okay? And now I also have to check at one point if I am incrementing, if when this j goes from I to I minus k plus 1, I also have to make sure that j is within boundary, correct? There could be no element here, and when I do j minus k plus 1 and if this goes out of boundary, I have to make sure that this j value, my window size, is within boundary. So for that what I'll do in my for loop, okay, for my for loop when I take j, so instead of directly taking the end of loop to be I minus k plus 1, I will always check if it is the end of the array or not. So for that I will take the minimum of length of this array comma this particular value, because if this is the length of the array and if after computation of this my j value is here, which one is smaller? This one is smaller, so by default I can take this. But in case the j value after computation lies outside the array, I can't go outside. The maximum I can stop is still here, correct? The maximum I can stop is still here. So which is why I have to keep checking that my j value lies within the array with this particular condition, and you keep calling the function again, and in the end you will just return your answer. You keep storing your maximum value everywhere. You call the function and you store it. So what are you doing first? You are starting a for loop from I to I plus k minus 1, okay? You are starting a loop like this. Now when you start the loop, you will check for the values here. You will take the maximum value here and you will check for the maximum value. After checking the maximum value, you will multiply it with the window size. You will multiply it with the window size to get the maximum sum, and then update the max value and then increment the I value and call the function all over again. So now the time complexity for this one would be you're taking n elements, okay, in the array you're taking n elements, and for all the n elements you're trying k sub-arrays, correct? One for one sub-array, two sub-array, and k times. For every element you're checking for k element of sub-arrays. You're checking n into k possibilities. So the time complexity would be O into n of k. And you'll be using a recursion stack space of n elements, so the space complexity would be O of n. Let's quickly code this up. We have a function maxSum after partitioning given, in which we have an array and the element k being sent, which is at most k elements in this subarray. Now, what are we doing first? We are, let's define this function, definition of helper, okay, helper of I, such that, now, what are we doing? If, okay, what are we doing? First, let's initialize our maximum value. What are we doing? Let's first initialize our maximum value to 0. Okay, and then also a result 0, where the result will be the maximum value in the end that is being returned, and current max is for every given subarray. We have to keep updating the maximum element every time we encounter a greater element. Now, what are we doing? For j in range I comma, what did I tell you? J must be within the range of the array. So we will always pick the minimum of length of this ARR and I of I plus k. Okay, I plus k, because the array, the j value must always be within the range of the array, so it will always be the minimum of length and array. So if I plus k goes out of bounds, we will be taking length of ARR. Now, what are we doing next? We will first update our current maximum element to the maximum element in the array. So what we'll do, we will check what the maximum element is. So it will be if it is current of max or the current element we are at. The current element we are at is ARR of I. So if we encounter a greater element than the current max, the maximum element will be updated, so that in the end, if for example our sub array is 1, 2, 3, okay, and our actual array is 1, 2, 3, 4, 5, okay, 1, 2, 3, 4 and 5. So what we are doing here, so when we come across 1, our maximum will be updated from 0 to 1. Then when we go to 2, our maximum will be updated from 1 to 2, and then when we go to 3, the maximum will be updated to 1 to 3. Now once the maximum is updated, what are we doing? We are taking that particular maximum element and multiplying it with the number of elements in that subarray to get the answer that particular subarray produces. So what are we doing? First we want the window size. So window size is equals to j minus I plus 1. Okay, now what are we doing? We are taking this large element and multiplying it with the number of elements. What will my result be? It will be the maximum of result, as in the previously computed result, and since my j will be moving one step ahead, okay, j plus 1. Now why j plus 1? Now imagine I have an array 1, 2, 3, 4 and 5. Now initially my subarray was 1, 2 and 3, and my I value was here, okay, my I value was here and my j value was here. For me to get a new subarray, which would be 4 and 5, I have to shift my I pointer to here, correct? For me to get my I pointer to here, what is I here? It is nothing but j plus 1, correct? My I value here is nothing but j plus I. Okay, so I will be moving there. That will be maximum of this plus the total value of this. Since we are going to multiply the whole thing as in get the result of that particular subarray, what is it? It is nothing but current of max, okay, into window size, okay, the current of max. So if there are elements like 1, 2 and 3 and maximum is 3, how many elements do I have? It is 3 elements. So 3 elements into the maximum of 3, which is answer is 9. So 3 plus 3 plus 3, or 3 into 3 is 9. Now what am I doing? I am going to store this result value in dp of I, okay. So now Why did I initialize a DP array here? This recursion method won't work directly. So for that, what I have to do, I have to take this DP array such that I don't have to compute this whole process for the element I if I come across it again. For example, if it's 2, 3 and 4, and if I already computed 2's value, I don't have to compute this if the value is already present, which is why I updated this to if I in DP, then return DP of I. So what will my answer be? It will be dp of I is equal to res, okay, result, as in then I will return my result in the end. Now apart from that, at what index does this function start? It starts at the index 0. It starts at the index 0. So I will return nothing but helper of 0. Okay, now let's quickly run the code. It's accepted. Let's just submit it. Alright, this works. Thank you guys.